Welcome to another session of the Knowing IPR. Today we'll talk about different aspects of software patenting. My name is Dolores Moditz and I'll guide you through a few slides on this topic. The idea is actually very positive. So what we want to do is, with an intellectual property rights, we want to compensate the creator for what they've done. Right? Because they've invested time, they invested resources, right? In terms of financial resources as well. And we want to make sure that that's something valuable, for example, for the companies, right? So that they do innovate as much as possible. But on the other hand, the trade-off is open diffusion of these novel ideas. And let me tell you what that means. So what the IPR will give them are certain rights to use their intellectual property in a certain way, but as a price to pay, it means that they need to be disclosed. For example, when you register a patent, you need to describe what the patent is all about, what's inventive about it, okay? And so we have different types of intellectual property rights depending on what they protect. Inventions are protected by patents. Visual designs would be protected by design rights. Some kind of identifying or distinguishing sign would be trademarked, right? And our original expression of ideas would be copyrighted, right? For Harry Potter book, we have a copyright on it. Coca-Cola, BMW, typical trademarks. The design rights, we can find them on anything, basically. Even a simple paper tissue, if it's not completely simply white and has some kind of ornament in it, it's pretty likely that will be a subject of a design right. And of course, then we have a lot of inventions today that are patented. And there are differences between all of them, not only in terms of what they protect, but also in terms of how strong they are, with patent usually considered the strongest one and copyright the weakest one. And you can think about, for example, there's a big discussion about, can I patent a computer program or not? Because if I cannot, my rights towards others will be much weaker than if I simply can have a patent. And by the way, I can have a patent, of course, if I know how to write one. There are two complementary elements to digital technologies. First, hardware, which refers to the physical components, right? We can have microprocessor chips, etc. Or we can have some external devices the computer could control. On the other hand, we have software. It includes protocols and instructions
which tell the hardware what to do, when and how. And typically, right, we don't have software without the hardware, nor do we have hardware without software. Hence, they are intrinsically connected to each other. If you think about patents, what they protect are novel and inventive products, right? Like physical hardware. But they can also protect novel inventive processes, even if those sequences of steps are carried out on a computer using software. And how typically the patenting sphere talks about such inventive products and processes is computer implemented inventions. When we talk about patents and inventions, we talk about inventions that solve some kind of technical problems, right? They can be products, they could be devices, they could be whole systems. But they can also be process methods or certain uses, right? Most frequent thought about patent and invention would probably be pharmaceuticals or chemical substances. There's also limits to patentability, and there is where it gets a little bit tricky with digital, right? Patents are typically not granted for business models or rules of game as such, and for a variety of different things, ideas, mathematical um, ideas, and so on, right? So what the problem becomes is this difference between the idea on one hand and the application, right? Um, in a sense that the software code would typically be protected with a copyright, as it is an expression of the idea. But if one can show that the piece of code is more than just some kind of mathematical procedure, that you can have alternatively done just with a pen and paper, but it's actually a neat piece of software, then what we can talk about are basically methods performed by a computer, and also the patent systems will be more inclined to allow such inventions to be patented. And we'll talk about this more in detail in the next slides. Another thing to keep in mind is that digital technologies are typically cumulative and complex technologies. And so there are many, many protected components in one product. If we think back at a smartphone case, right, and we go way back to IBM's Simon, which was introduced in 1992, right? It had a touch screen, about an hour of battery life, some internet games as well, um, which actually flopped in the market not too long after its debut. However, what we can see even there is looking at subsequent patenting that there are a lot of different things that are covered in different patents, a lot of different aspects, right? From field programming, how to update, how to zoom, right? How things are contrasted, etc. Right? So basically, a smartphone combines very many communication and computing technologies. And today, this is even more so the case. There are some studies saying that there are about 250,000 patents or more that are in the area of smartphones. That also means that the innovation in this field is pretty limited by the existing patent rights that are on the market. even more so if we would look at other types of intellectual properties. Here is just a little overview, right? You can have trademarks, can have copyright, you can have the patents, right, on the operating system, on the user interface, on how data is processed and the methods related to it. Of course, you can also have design as well as trade secrets. So that makes it a pretty complex field to look into.
So emerging from the nature of the digital objects, there are also shifts in how we think about managing the digital IP and how we manage it in reality. So digital inventing is different, and those who master it develop patent portfolio along use cases, and we'll talk about this in just a moment, like developing software along architectures. The way, the approach on how we create digital invention is also slightly different. There's a joint approach among the creative and IP part. That's not to say that the IP part isn't creative. But they jointly create, on purpose, a digital object that is patentable. So it's not a classical waterfall or stage gate process. Digital inventions are also different, and so are digital patents. Digital inventions are more abstract, they're broader, they're more aligned with the business model and the use case, and are not only based on the classic technicality or a technical solution. Therefore, also the related patents are different, right? They would be more abstract, they would not come from physical reality or technical functionality, but rather from the application, the solution, the use case. That, however, sometimes tends to be a problem in terms of patenting and the patent application itself, because not only do you need a technical solution to patent, you also need a technical problem. And again, we'll talk about this in one of the next segments. Freedom to operate for digital solutions is also different. It's not a good idea to produce an app and ask questions later. The competition does not necessarily come from a familiar technology. It might not even come from the same product area or field, and so the solutions become complex, and so does the freedom to operate, which is then also more complex and more complicated. What I want to do now is take a look at Signify. So Signify is the lighting branch from Philips, and indeed until 2018 it was called Philips Lighting. They have a revenue of about 6 billion, and what's interesting is that they get 3 billion just from licensing out hardware and software and patenting rights for different lighting solutions. As a case, let's look at their evacuation of offices solution. So there's always a changing population of people, and hence you need different algorithms that talk about how to optimize the evacuation. And of course, the Signify solution is using LEDs for evacuations. But what's interesting here is that these kinds of patents don't come from R&D results as such, but they come from use cases. So they want to license out a use case, hence they apply a use case patenting strategy. So active IP design and IP management for digital solutions means that the starting point is the business case. But the design will be both the business object and the necessary IP. Let's look now on how do we then approach patenting and the IP when we talk about things that are related to software. Of course, we know that software patents, software solutions as such, are difficult to patent. So what companies now do, they use different layers of technical realization and try to connect that to the software they have. So it's basically an interplay of software and the physical world. Or in other words, they look at the technical realizations of the business model. Here you have the case of Netflix, for example. And it goes from the first layer of the physical product up to the digital service, and they have patents on everything. So if you think about some of these inventions, for example, we'll look into this technology on connected to showering. So a showering head is, from a patent perspective, pretty boring. It's been done before, it's been patented, but then we'll use kind of an additional layer, and there's where the magic happens, because from the IP success or success of this solution within the market, what user sees is just the digital service, the last part. But in order to make sure that the profitability is exclusified, you cannot aim only to the layer of the digital service. Let's move to another case. This is the Tencent. It's the Chinese Google and Netflix all in one. And what they're offering, or what some of the platforms want to offer, is watching content free of commercials. But of course, the content costs. And so there needs to be another way how to do this. And Tencent is cooperating with a company called Myriad, which is a patent holding company for artificial intelligence. And let's think about one of the cases, okay? And this is the artificial intelligence product placement. So you have some content and you're watching it. And traditionally, how the product placement worked was, it was basically a fixed thing. For example, we know that James Bond was driving a S. Martin, had an Omega wristwatch, but once it was embedded in the content, it became fixed. However, today there's a shift to kind of radical individualization. So what AI is doing, firstly, is analyzing the video scenes and looks for opportunities to integrate an advertisement. And it can be on the wall of the building, it can be as part of a window reflection. But it's also smart enough to analyze content. For example, inserting skiing boots as an object inside the scene is possible, but probably, for example, having those skiing boots inserted on a desk in an office in Tokyo, where you have a typical office scene, wouldn't work, right? And additionally, the AI is looking into your search preferences. So it's analyzing, again, the segments that you watch. And so, for example, for me, what I would be seeing would be a coffee cup that had integrated brand A, whereas for you, maybe that coffee cup wouldn't be a coffee cup anymore, but it would be a cup of Coca-Cola or some other beverage. But again, you can see also here in this example of the Tencent and Myriad, as that they go systematically through the technical layers and try to figure out how to gain patents on each of that layer, one or more, of course, right? So in the end, the whole business model has exclusivity, and the profitability has exclusivity. Let's have a look at patenting software patents, or at least so-called software patents, at the European Patent Office. If I go back to the basics, and I already pointed out this, as you need to have a technical solution, so you must have technical features that define the scope of protection, but you also need an objective technical problem. Another thing that is super important is that, per se, programs for computers are not regarded as inventions. However, such subject matter is only excluded from patentability if the patent application relates to such subject matter as such. And we'll see that this is in reality not such a high threshold. Of course, you can have some cases where the software is only non-technical, but more often than not, a computer implemented innovation is a mix of technical and non-technical aspects. And it can also be that the non-technical features dominate. However, those non-technical features cannot be counted towards the inventive step. Typically, the computer program must have a further technical effect when run on a computer, so it needs to go beyond the normal interaction between the software and the hardware. But these days, there has been a lot of patenting of solutions, such as, for example, rain tunes, where, as you can see, there's a technical implementation as these rain tunes are connected to the shower fittings, right? And the service in the end is a kind of lifestyle well-being invention. But again, thinking about the layers is what needs to be done, and these layers need to include technical aspects, technical features in the parts where patents will be successful. However, there is a clear distinction between the features related to kind of business administration, customer and marketing, and those that are considered technical features. I mentioned that today patenting software patents is not difficult in terms of the subject matter not being statutory, so to be deemed as something that you cannot patent, because the claims, and those are the heart of every patent application, must have a technical character, but a single technical feature suffices to go through that barrier. The problem begins where we think about inventive step, because only features that contribute to the technical characters are taken into account. And on the other hand, they mustn't be obvious. And that's the part that presents problems these days. So at the EPO, the examiners are taught to use so-called problem solution approach. And there are basically 3 steps or stages to it. You need to, well, first you need to look at the invention. Then you need to find the closest prior art, which can be another patent, could also be something else, a publication, a product that is already sold on the market. But then you need to see if the invention is far enough from the closest prior art. So you need to determine the difference. And the difference needs to be in some kind of technical effect, and needs to solve a technical, objective problem or objective technical problem. And then one needs to consider whether or not this claimed invention, when you start from the closest prior art, would have been obvious to a skilled person. So if it would be obvious to a skilled person, then you will not get this patent. And let me exemplify on the next slide this with a very simple example. So this is an example how you can frame the problem in 2 different ways, but basically you have the same solution, and your service to the end customer is basically the same. So what you want to do is improve the readability of text in the user interface. But the left-hand side formulation would not go through, because it says by using specific different colors for the text and the background of the text. So it's pretty non-technical, right? It has more to do with psychology and understanding the consumer. However, you can reframe that same solution in a more technical manner. So you're still having a user interface that's improving the readability of the text. But what you're saying now is that you're solving this by considering the resolution and the frame rate of the display. So you're addressing a technical problem. So what you have to do is either keep this in mind from the beginning on, as you draft the patent, or you have to be able to kind of reformulate the problem later to fit the patenting criteria at the patent offices. Let's move now to the last part, and it also nicely shows that in some cases how you would patent something that's related to digital at the European Patent Office versus the US Patent Office would be different, but then some parts would not be, right? When you have the problems with either EPO or USPTO, it's usually so that the EPO is kind of the gold standard, meaning that if you got the patent through at the European Patent Office, you will most likely get it through the USPTO, even if you will have to perhaps broaden the patent a little bit. So sacrifice a little bit of the patent, what your patent is covering. But in other cases, neither of the patent offices will budge. And I want to start off this this part with an interesting story of the artificial intelligence being an inventor. In February, I believe, at least that it was February of 2020, two Dabus cases came out at the European Patent Office. Well, and especially their decisions. Dabus was described as a kind of connectionalist artificial intelligence and designated as the inventor. And then the applicant said, well, we have the right to it by being the successor of Dabus in title, since they are the machine's owner, right? And then what they were saying is, well, this machine identified the novelty of its own idea before any natural person did. And so they said, well, they should be recognized, or Dabus should be recognized as the inventor. Did it go through with the EPO? No. EPO says that only natural persons can be an inventor. Let's look at how the USPTO reacted to this. So what did USPTO say to artificial intelligence being recognized as an inventor? First, maybe a good question is, how come this came to the EPO and USPTO? And it's also argued the same case, for example, in UK. Behind it is a project called the Artificial Inventor Project. And what it's arguing is that it might be necessary for an AI to be listed as an inventor, so not to own it, just to be listed as an inventor. But that might be necessary when hundreds or thousands of employees contribute to a code, to a system like the Watson. And then the computer just goes on to solve a problem. And if no human would then be involved closely enough with an invention to claim credit for it, then you're out of an inventor, but you need to list an inventor. So that would basically mean that you couldn't patent these kind of inventions at all. So what happened here with Dabus, with this artificial intelligence? So Dabus was fed with a bunch of information, including abstract concepts related to design, practicality, color, emotion, and then this AI program design, 2 inventions. And one is a shape-changing container, which would be easier for machines to grab, right? We still know that in robotics, we still have some issues in terms of their interaction with different objects. And the second invention is so-called neural flame. So it's a flickering light that mimics brain activity, and its benefit is that potentially it can be more effective at catching a person's attention in an emergency situation. So again, we're doing a case related to emergencies. However, USPTO answer was same as EPO's, at least for now, saying that only natural persons can be recognized as inventors. So the other question is, can you then patent an AI? But the algorithms underlying artificial intelligence and machine learning are typically considered to be abstract, mathematical in nature, and general not considered to be technical. And we actually have an extract from the guidelines for examination from the European Patent Office, and it gives various suggestions to their patent examinators that need to put their stamp of approval to any patent you want to have granted. And so what they're pointing out sometimes is also some specifics, like if the claim subject matter has a technical character as a whole, expressions such as support vector machine, reasoning engine, neural network must be looked at carefully, because they usually refer to abstract models devoid of technical characters. So turning the story on its head, basically using those expressions can be tricky. But let's look at on the next page what has potential to be patented anyway. So there is some leeway in 2 distinct cases. One are so-called technical applications. So the artificial intelligence or machine learning is claimed for a specific technical purpose. A typical example would be where artificial intelligence or machine learning are used for controlling machinery. So this kind of specific technical purpose must be recited in the claim. And so the claim must be functionally limited to that person. These are somewhat more common in practice. Then you also have so-called specific technical implementations. These are rare. So the AI or machine learning solution is specifically designed based on technical considerations relating to the internal functioning of the computer. So what it means, the claim must be basically directed to mathematical steps that are specifically adapted to exploit internal functioning of the computer on which they are implemented. So it does go to say that the claim does not need to be limited to technical application, but one needs to be very careful with this. there are interesting shifts in patenting digital solutions or patenting computer implemented inventions. So that can be either methods performed on a generic computers, or methods that require some specific means, or methods implemented in a distributed environment. But sometimes or many times we simply call these software patents, or patenting software. What we need to take into account is that not only the solution needs to be technical, but also the problem must be technical when framing the patent. So you either need to take this into account from the beginning on, or you must be able to pivot and thus reformulate the problem statement inside the patent at a later stage. One also needs to understand the difference between technical and non-technical features and be cognizant of the fact that the problematic step in the patent process isn't really one of statutory matter, because basically only one technical feature will save you there, but the problem part is that of the inventive step area. Thank you for taking part into this, software patents session of the Knowing IPR training. Feel free to contact me via email should you wish to continue the discussion. Thank you.